We are going to look at problems that start with a log in them and talk about how we might solve it. In doing this, we need to make sure that we isolate our log first and then try to change it into exponential form. So if I'm trying to get the log by itself, that means I need to get rid of this 5. There are 2 different options for getting rid of that 5. Can you tell me one? Divide the 5 over. What's the second thing you could do with it? Right, it could become x plus 3 to the 5th power. Would it be easier to have an x plus 3 to the 5th or just to divide the 5 over? Probably divide the 5. You'll get the same answer either way, but this might make it a bit nicer. So then we would have log of x plus 3 equals 2. Now if there's a log on one side, we can change it into exponential form. What's the base of this log if it's not? This would be 10 squared equals x plus 3. So subtract the 3 over and we get 97. You do have to check on these because the original problems had logs. We've talked about if you have a log, the argument has to be positive. So that's really all I need you to verify, that if I plug in 97, both the base and the argument have to be positive numbers. Is 97 plus 3 positive? Yes, so it's fine. If you had done this problem the other way, just to show you, so if you had written it as x plus 3 to the 5th power, you would still get there. So this is a base of 10, so you would have 10 to the 10th equals x plus 3 to the 5th. Now 10 to the 10th is a huge number, but how do you get rid of a 5th power? The 5th root. When you do that, it's like dividing these. 10 divided by 5 is 2, so that would turn into a 10 squared. And that should look familiar. That's what we picked up here. So even if you turn it into an exponent, you'll get to the same place. It just takes a little longer to get there. So I don't know. All right, now on this one, can I just divide by 3? No, because we have 2 terms on the left. We have to condense those, put them together somehow. So if I can't divide by the 3, what would I have to do with it? Take it to it would go back into the exponent, right? If we can't, because it's not everything times 3, since those logs aren't in parentheses. Now at this point, can I change it into exponential yet? No. That definition requires me to have a single log over here. So is there a way to combine those logs? Yes. If 2 logs are subtracted, you can put them together with division. This is why before Easter break we were doing so many of these problems where we are condensing these logs to help prepare us for these equations. Now I have a log just on one side, so now we can change it to exponential. 2 to the power, that's nice 1 cubed over 4. So we'll have to multiply with 4 over 2 to the 5th is times 4.
128.
Okay. How do we get rid of a cube?
Take the
When do you have to have a plus or minus on these?
It's a square.
Yeah, anytime it's an even root, so like a square or a fourth. Does the cube root of 128 work out nicely? So we could give a decimal, we could keep it, but then what would be the next step? So we would have an x minus 1 equals the cube root of 128.
I have one.
Mm-hmm. Alright, so this is your exact answer. You know, Math Excel last night, sometimes it said exact answer. We could also give an approximation if we put it in the calculator. So the cube root of 128 plus 1 is about 6.0397. So if I ask for the approximation, that's your estimate. We do have to verify that the argument is positive if we were to put that back in. So if you put in about a 6, would 6 minus 1 be positive? Yes, so that's okay. Any questions there? Thoughts? Okay, why would I need to move it to the other side?
Because you know the logs on one side.
Yes, we have to put these logs together. Alright, once I add it over, can I drop the log yet? No, so what's the next step?
Condense it.
Condense it. If you have logs added, then how do you combine those?
Multiply.
So that would become the natural log of x to the third. Okay, the base of a natural log is, so we change it into exponential, so e to the 9 equals x cubed. To get rid of the cube, we cube root it. So if you want to simplify that, that's like 9 over 3. 9 over 3 is 3. So x equals e to the third. Or if I ask for the approximation, you can do the e on your calculator. The third is about 0.0855. If we plug that back in, is it an okay answer? Yeah. Why don't you guys try the next one? See how far you can get with it. Okay. If logs are added, how do you put them together?
Multiply.
So we have to take x plus 7 times x plus 8. So that means we have to FOIL. So we get x squared plus 8x and plus 7x would be plus 15x plus 56. Then we have one log, so we change it to exponential. So 2 to the first. 2 to the first is just 2, so if you subtract that over, so what multiplies to 54 and adds to 15? So if those equal to 0, we get negative. Alright, and then what do we have to do? Okay, if we put in negative 9, is negative 9 plus 7 positive? No, so we cannot use that. We cannot do the log of a negative number. Is negative 6 plus 7 positive?
Yes.
Is negative 6 plus 8 positive? So negative 6 is the only answer. Alright. Any questions on that one? So all of the problems we've done so far have some terms with a log and some without. You know, here we had 2 logs and then a number by itself. 2 logs a number. And our strategy is to get those logs into a single one so we can change it into exponential. But we might also see problems where we have logs on both sides. And then our strategy is going to kind of go back to yesterday. If you have 2 logs that are equal, that means the arguments have to be equal. So yesterday we were starting with something and adding a log to each side. It's also legal to take away that log on each side. But it has to be set up like this. 1 log is equal to a second log. So you might have to condense or simplify some things first before you are able to drop those logs. So if I'm looking at this problem, is it set up where I can just drop my logs? No. What do we have to do? Right. Would it do me any good to divide the 2 this time? No, because this side has a log, so it would just make that log divided by 2. So that wouldn't help. We'll have to move it into the exponent. So log base 5 of x squared is log base 5 of 9.
Since there was some logging, it would just be equal.
Yes. So we have a log base 5 on each side, a single log base 5, so we can make the arguments equal. Square root, anytime you add an even root, you have to do plus or minus. So we get positive and negative 3.
So does this only work whenever the bases are the same as?
Yes. So if they were 2 different bases, we would not be able to solve it like this. Are both of those okay answers? Right. The original problem had log base 5 of x. You can't do log base 5 of negative 3. So x equals 3 is the only answer we can use. You guys try this one. So take up your exponents. So we have log base 3 of x to the 1/2 equals log base 3 of 2 squared. So we can drop the base, log base 3, and make it x to the 1/2 equals 4. A 1/2 is the same thing as saying the square root. How do you get rid of the square root? So we get x equals 16. Check it. It gives us a positive argument, so that's okay. Thoughts?
Go ahead and combine the 2 elements.
Mm-hmm.
And a redivision turns
Right. So we write the ln once, 24 over x plus 4. Now we have 1 ln on each side. So that means we can next step. So for 4 of those, we get x squared plus 10x plus 24. I subtract over my 24, x squared plus 10x. What can we take out?
X.
Get x to equal 0 and negative 10. Checking. Is 0 plus 4 positive? 0 plus 6 positive? So that's fine. Is negative 10 plus 4 positive? So negative 10 doesn't work, and 0 is our only answer. one more like this. Where do we begin?
You want to combine them, and then you want to use division because there's subtraction, and then you want to separate each.
So set our arguments equal. And now what do we do? So if I multiply those, we FOIL, we get x squared plus 2x minus 3. This gives us x squared plus 4x minus 12. Okay, if I subtract over my x squared, those cancel. If I subtract my 4x, I have a negative 2x. Add my 3 equals negative 9. So x is 9 over 2, or like 4.5. So double check, is 4.5 minus 1 positive? Plus 6 is positive, minus 2 is positive, plus 3 is positive. What if one of those turned out to be negative? What would my answer become?
No solution.
No solution. And it is possible to have no solutions on these, so don't assume an answer will always work.
Yeah, there's some
Were there?
Well, that
yeah,
one was
because there were negatives.
yeah, it was just like this blah 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 is equal to log and like negative 6 or something, and then some blah, something like that.
Gotcha. I kind of forgot to put that question on there. It's making you think, wasn't I?
I had to use the example.
Okay. The last thing I want to do today is just some examples from the past 2 days where everything is mixed together. Because we've been solving one type of problem at a time, I want to see if I put them together, do you know what your strategy is? So what would I do on this problem?
You could try and
Check for a common base. 3 and 0.4. Is there a common base? Probably not. So then what do? We add logs on both sides. That's what we did yesterday. So you can do log base 10 or natural log. Since there's no e, there's really no advantage. And then what happens?
Divide over log 3.
Not yet.
Oh, wait.
move the 2x minus 1 to the front.
Exponent comes down. And the x comes down. Okay, so I have x's on both sides, and I have to get these together. Right here, we're still multiplying with the log 3, so I would probably distribute that first. So we have 2x log 3 minus log 3 equals x log 0.4. We'll subtract this one over. How does that help me?
Okay, calculus.
finish it and get x by itself. Very difficult. So that's my exact answer.
I think that's pretty similar to what my question was.
Okay.
Because like the log,
You wanted to
3
cancel
log 3.
those.
Yeah, I wanted to cancel
The
those.
reason you can't is there's technically 3 terms here.
Mhm.
So all 3 of those would have to have a log 3 for you to cancel.
Okay.
So it's because of this one log that you can't.
Okay.
If I ask for a decimal approximation, everybody plug it in, make sure you can get it to work. Bless you. Thank you. You get about 0.3529. And how can you check yourself on those? Put them back into the original and see if they work. Let's do, I'm not going to do all of these extra problems today, I'm going to save some for tomorrow. Let's do C.
We would add 5 over and then divide by 6.
Mm-hmm. Can we get a common base? So what do? We have to add our log so that we can move the 2x plus 1 down. Now what? Divide the log 3. Then we need to. So, definitely not pretty the way we have it. To the negative 0.1845. Is that okay? I want to go to E. What would we do on this problem? We have to combine those by multiplying. So you distribute your x, so that makes it x squared plus 15x. What's the base on this log? Change it to exponential. Quadratic, so we have to get equal to 0. So the x squared is 15x minus 100. How does that factor? So 0 and we get negative 20 and positive 5. Do both answers work? I am stopping here today. Tomorrow we will finish the rest of these extra examples. So there is a Math Excel assignment open with practice just on the log problems that we are solving today. So you can work on that now and